So in this video we're going to continue where we left off on the city distance project, and I asked how can you improve this program, and if you look at it, it's staring you right in the face. The problem with this program is we have duplicate data here. I mean, this data up here is just a mirror image of the stuff that's in the bottom. Do we really need this information stored in memory? Okay, can we come up with a way to store these numbers? Look at this, 983, 983, 787, 787. It's a mirror image, okay, along the major diagonal, flipped along the major diagonal. So what you want to do is think about how can we get rid of this duplication, okay? So let's continue with it, and this will require a little bit of thought on your part, but I'm going to show you the end result, and that's going to be the second version, version 2, and let's get rid of version. First off, to activate version 2, I need to go in my main program and call class version 2's distance version, and okay, it's saved. Let's get rid of this guy right here and take a look at the version 2. And in version 2, the city's array is pretty much the same, but the matrix is still a two-dimensional matrix. So we're not going to call this. We're not going to worry about. We're not going to look at this code too deeply, other than to look at the bottom, the stuff that's here. And the two-dimensional matrix is not just it's not a square matrix. It's not a rectangular matrix. It's just storing the information that we need to store in order to look up the data. Now, if we go, I probably should have got rid of that other one. If we compare this matrix with this matrix, you'll see that I'm storing just the lower half of the matrix. Now, if you take a look at what we got here, we prompt for the indices. Great. If the row and column is equal to are the same, that's like saying, what's the distance between Boston and Boston? Well, you're already in Boston, so we'll figure there's 0 miles there, and that's consistent with what we have here in the first version here. Row, if you go along the major diagonal here, okay, that represents a row and column equal to that are the same, right there. So just return 0. Don't store that value in there. Now, if we have the situation where the row that you specify is bigger than the column, okay, if the row that you specify is bigger than the column, what would be like this guy right here, this particular number, anything on the bottom here is the row value being bigger than the column value. Like 787's got row 2, column 0. Okay, what we're going to do is say, well, let's see, what are we going to do here? We're going to take a look, and we're going to say, access your distance matrix, okay, but row -1. Remember, we lost that first 0 here. This thing here is lost. Picture these numbers pushed up. So instead of having a 1, 2, 3, 4, 5, 6, 7 element array, we're going to have a 6 element array, and that's what we have here, right there, 6 element array. So we got to make sure that whatever row you specify, we have to subtract 1, and then use the column to access it. So you'll access the proper value. Now, if column is bigger than row, okay, what you're going to do, if column is bigger than row, what you're trying to do is access this top half that doesn't exist in the second version. So what you're going to do is change the interpretation of column and row. We're going to use the column as the index for the row, -1, column -1, and use the row index as the column, and you'll end up getting the proper value. Nice thing about this, you need to really wrap your head around that, but it doesn't require that much thought. You can take a look, and the nice thing is we did some major surgery in this it's the second version, because the main program, other than that, this change didn't really count because I had to access the proper method in the proper class. But the main program doesn't have to change. Okay, we did some major surgery in the method. The method gets called, and The main method doesn't really care how it gets those numbers as long as the numbers that get returned are proper. So you have a separation between the classes. The main method uses the services, and the class city distance data provides the services. So you have a separation which you need to put in your program. So in this case, this is a great example of having a multi-file program system. Okay. Now, picture what happens. And so that's nice. That's good. Geez, wouldn't it be nice to say this was a legitimate map where you have thousands of cities? Okay, you're going to have. This is not a good way to initialize this map. Okay, you're going to have 1,000 lines with those numbers in there. It's unwieldy. Okay, so what I propose is the next version that we read a file. Okay, we read a file. Let's take a look at the file. Notice the file almost looks like, basically this is the same data that I showed you before inside that file. And we have our cities listed here. This number 7 means that we have 7 cities to read, and from that 7 we're going to establish an array of 6 elements, and we're going to build that array from the data file. The nice thing about this is that, you know, as you add more cities, you can just change the data file. The main program doesn't change. So let's take a look at the third version right here. And what I'm going to do is make sure that third version gets brought into the program. Let's see, where's my main program? Main program right here. My main program, this is be the third version. And we're going to save that. And let's take a look at how we're going to do this. Okay. I was experimenting here. Data, city distance data. All right. So I want to show you something here. Some nice features of Java. Okay. When the class gets when the class gets brought into the system. Okay. City distance data 3. All right. We're going to run a code block that initializes the cities array and the distance array. Notice there's no data inside these arrays. These are just declarations of variables that's going to hold the data. Okay, but when you bring in city distance data 3, what's going to happen is you have a code block that automatically runs. Okay, it's not really a method; it's a code block. When this class gets loaded into memory, Java looks for any code block that looks like this, static with some braces. And what I'm going to do is I'm going to call this distance matrix method. This is where I'm going to get my data. If there's ever a problem, I'll put a little message here. But this is this distance matrix. Notice it's private. That's good. You want control over this. Okay, and so what we're going to do is, you know, the typical way you read a file, we're going to read the number of cities, that, okay, I guess is 7. We define the storage for those cities, so city distance data. I could have done this. Just say, let me say, edit, cut. Cut, where's my cut? Cut. Okay, I could have done that. It still would have worked, but let's just do edit undo here because I want to show you that I'd like to put the class name in front of the variable. As soon as I see that class name, I know it's a class, it's capital letters, and so cities is going to be a static variable within the class. The code tells you basically what the purpose of that variable is. See, if I highlight that, we have this. And so we read in those cities, and then what we have to do is build that ragged array. Okay, so if we have 7 cities, we need to define an array of 6. That's why there's the -1 here. 6 one-dimensional arrays, and what we're going to do is create the array, so on row 0 we want an array of 1. If row 1 we want an array of 2. So this establishes the storage, and then what we're going to do is inside that file we're going to read from your input, which is right over here. This input is your file. We're going to read those numbers into the distance matrix, and now you have a nice initialized array, and notice the distance doesn't change. This method didn't change. So let's see if that works. I hope it works. Where's my distance matrix? Distance matrix right there. There, we gotta make that active. Run it. Okay, distance data 3 gets started. Let's see, Boston, New York, and we read the file and we got the right data. Now there's something that you have to understand here, is that city distance, when you start the main program, city distance data doesn't get brought in, okay, because, let me just show you this. And you can't sense it in the computer because it's kind of fast. See, I started the program. City distance data is not in memory. It's not in memory. It doesn't go in memory. It doesn't go into memory. See, until let's put New York in there. It doesn't get into memory until we get to line 13, where you explicitly say, I would like this class, the method inside this class. It brings it in. This is when it starts. Okay, well. This is when it starts loading that data. Okay, and just to bring this idea home, let me do something here and say, listen, system dot out. Let me just show you that print line loading data. Okay, so we're going to show you this. This is going to be a neat little let's put this on the side here. Let's run this. Okay, notice you didn't see any loading data there, did you? Boston. And we're going to call this New York. There's your loading data. That's when it gets called. That's when it gets brought into memory. Now, if this file were substantially large, like there's a ton of cities in this world, and say it's you have a gigabyte of file to read. Okay, what's going to happen here is after you type in that New York, you might sit there and wait a long time for the for this thing to load into the class. So you might want to preload your classes before you actually use them, and this is where I put this statement. This guy here preloads the class so that it reads the file and brings that information into the system. Okay, so let's show you this. This preloads it. Come on, baby, you can do it. Okay, notice we loaded the data. So it's guaranteed, while I'm sitting there typing the name Boston, okay, it's guaranteed that that data is inside that class, that I can do the lookup. See? Now, let me show you the last version. The last version of this is going to be version 4. Okay, so let's put version 4 in there, and let's comment this out. Comment that out. I don't want that in there. Let's bring in the version 4, and let's save this version. And what's so special about version 4? Version 4 is pretty neat. Okay, this is using a file that's in my personal web server. Okay, let's copy this URL here. Let me show you. Copy. Okay, let me bring in a browser and show you that it's somewhere buried in my in my paste. In my personal directory, I have a file. And if that file doesn't that file look exactly like the file that was in my project in version 3? See, the problem with version 3 is that you have to distribute that data file to all the people that decided to use your system. Now, if you go ahead and you change the add more cities or change any erroneous entries, the people that downloaded your system don't see the changes. But if you put this, if you write your program so that it reads the data file that's on the web server, you update the web server, and everybody that uses your service is going to see the updates. So let's see how we do that. It's not that hard. In fact, it's basically it looks like the version 3. The only difference here is that we have a nice little constant that points to where that file can be located. Okay, same cities and distance matrix. This looks the same as what we had before. The only real difference now, see this, we have the URL string, but now this is the magic here. Convert that string to a URL, and on that URL we're going to open up a stream of bytes, and then the scanner is going to read those stream of bytes, and then from then on it looks exactly the same. We read the number, we read the cities. This is the same code as version 3. It's just that the scanner now is tied to a URL and that URL has an open stream. So now basically this provides a bunch of bytes that the scanner can use to process, and now a lot can go wrong with this, and so as you code this, you're going to need to tell the system, hey, this particular method could possibly throw a malformed URL expression. So if I typed in some gibberish here, okay, that's not a URL. That's gibberish. That'll be a malformed URL. Don't even try to open up a stream on that. It's going to throw an exception. Okay? And then when you do any type of networking, there's going to be an I/O exception possibility, and that's certainly the case. If the router goes down as you try to access that file, that there's a chance that that could happen. So it's telling Java, hey, prepare for that. Now we've seen that throws cause before, but we're gonna look at that in much more detail when we get into exceptions. But the rest of this code is the same. Let's run it. Show you something here. Let's show you this. It's called this version 4. I didn't do any preloading, and I think you'll actually see the delay. Okay, I'm going to put in Boston. I'm going to put in New York. Now I'm going to hit enter. There's a little delay there. Look, then you got that. All right, and then you got that delay because now we're reading that data from an external source. Now, if that delay becomes a problem, then you can always preload, okay, that class. Always preload that class. Let's run this and put Boston in there. New York. Enter. Look how fast that came back with the preload. So I think you learned a lot of techniques with this little project here. I hope that you would use it on your homework assignment. All right, we'll see you. I guess this is the end of the videos for Chapter 8. We're going to make some videos on Chapter 9, and but there will be a homework assignment for Chapter 8 that you can probably use this code in there. All right, we'll see you next Chapter 9.